Here is a Kawasaki servo motor we have repaired for one of our automotive customers. It is a 3MC302G 3 kilowatt model. This type has a 14-pole motor and an H32 type serial data encoder. It has been connected to our servo rig for final testing. Before we carry out the final test, we check the motor by running it in both directions to check for correct operation. This ensures the motor controls correctly and the alignment is accurate. Our servo motor test center was modified to run the 14-pole motor. The H32 serial encoder data is a Kawasaki-specific 14-bit rotating serial code, which translates to 512 unique position increments and 4 fraction rotation bits. This gives a total resolution of 8,192 counts per revolution. Our test rig interface reads and decodes the data in real time, then completes the speed and accuracy calculations to commutate the motor to full speed. The motor is coupled to the load rig section of our servo test center. The test engineer checks the operation of the motor. He runs the motor at full speed and applies maximum load to the shaft, in this case 10 Newton meters. The drive and the test center settings are adjusted to suit this particular model of servo motor. The test engineer then sets a test program which applies a load profile and drives the motor in a way that would be seen on a robot or machine tool. This part of the test shows the motor running at full power against a load. After a period of time, the load motor is viewed with a thermal imaging camera to check that the surface temperature is even and no hot spots are present. The motor has a uniform surface temperature of 49 degrees centigrade after a 30-minute test. Once all the tests are complete, the engineer will compile a test report that shows the motor performance results. We record and document the current per phase, motor power, torque applied, and encoder outputs. These are checked against the OEM data before the motor is shipped to our customer.